Giovanni asked me to speak to you, I ran to my local bookstore. And I went to the rack. You know that rack where you look and it says, learn quickly about a subject, right? The history of math, the history of time, right? And they all have the same formula, right? They start with the pyramids and they sort of end with Einstein, right? But I couldn't find one on data. So today, I am going to write my own little book for you, right? I'm going to go through the history of data, and on that journey, hopefully we can learn something which applies to the Caribbean. So the thesis that I'm going to work with today is this. So throughout history, the countries that produce, organize, and act on data are the ones that innovate, accelerate, and ultimately dominate. And that applies to, going back in time to early societies through to our contemporary global order. And I'm going to start 8,000 years ago on the plains of Mesopotamia. And I'm going to start with an Ubed farming community. Maybe one hut, maybe two, maybe three. And of course there's data here. But you don't need the data. You can shout from one end of the village to the other, you're all good. But 3,000 years in from that, we have the Sumerian civilization. And those villages turned into cities. And walls surrounded those cities that went on for miles. And those cities were up to 80,000 people. And suddenly you had an explosion of data and surplus products. So you had surplus products because you had to manage this huge city, and surplus products led to a complex economy. So you had a complex economy, bureaucracy, trade, taxation, resource management, and you needed accountability for all that data. So you needed to audit it, you needed to track the goods, you needed to work out, debts and contributions. And so what the Sumerians did is they worked out how to record data. That was their big innovation. And they threw it on these clay spreadsheets. You've seen them, right? The cuneiform clay spreadsheets that look a whole pile like a spreadsheet from a farmer in, Kansas, right? P&L. And all those clay tablets, about 90% of them are economic and administrative records of trade, harvest, taxes. And going back to the thesis, civilizations like this that produced, organized, and acted on data, they thrived, they innovated, they accelerated, and this society dominated for 3,000 years. Let's skip over to Rome. Okay, so we're talking, 600 BCE. We had King Servius, who put together the first census. Why? Because he wanted to work out who in his society could come together to be an army to defend Rome. At that point, he went out and worked out that approximately 80,000, obviously the number of the day, 80,000 people could be gathered to be an army to defend Rome. And collecting data equaled to him military and fiscal power. And you'll see that throughout this little storybook that I'm writing here, for Rome, data was power, right? It was the blueprint for centuries. And so if you pedal forward, you have Julius Caesar. Now, Julius Caesar didn't quite get data. He applied a 1% tax across the Republic. But what he did is he delegated it to what he called tax farmers, right? They approximated the amount of tax that they would collect. So there was a huge amount of mess. There was a lot of corruption. And it was only when our hero, our data hero, Augustus, came in that things started to hop and move ahead for the Roman Empire. So what Augustus did is he was, of course, in Rome, but he realized there was no way that he could delegate the responsibility of counting out folks so you could tax them. So he did away with these tax farmers, and he instituted a regular census, and he put out these census takers. And they went out to all the different parts of the empire, and he decentralized data collection. Right? So in every country that was part of the empire, North Africa, Spain, Germany, Greece, Persia, Israel, you had these data collectors, these census takers, right? And they collected data, and you see this in murals, for example, depicted in Byzantine murals. This is, from a church in Syria, where you have the Syrian governor, you have the census taker, and then there's a line of folk, and of course in the front you have the Virgin Mary and Joseph lining up to get their census taken. Now, I have to admit that the actual original mural was a little blurry, so ChatGPT helped me a little bit there, but it looks almost identical. And so what happened is all this data was collected, and then it was sent back to Rome, and it was collected in a central database. In Rome, it was called the Atrium Libertatis, right? The House of Freedom. Why House of Freedom? Because we only counted the people that were free. And their data was recorded. And then going back to our thesis, right? Rome flourished. Why did Rome flourish? Because it acted on data. It used data intelligently. And it grew the empire twice the size of Julius. And for 200 years, there was peace, Pax Romana, and roads were built, aqueducts were built, public buildings. There was incredible rise in trade, in jobs. Let's leave Europe. Okay, we're going to go across the Atlantic, and we're never going to come back, right? Because we have a data sprint from 1790 to 2025, and it all happens in the US, right? So in 1790, we needed to count data. Why did we need to count data? Because at that point, there were 3.9 million people in the US, and they needed to reapportion the seats in the House of Representatives because they had a big war debt to pay off. But the problem was that the US was growing so fast. It's 30% every year, and every decade they had to count all this information by hand. And you can imagine how long that takes. So in 1872, this guy who was the chief clerk of the census, Charles Seton, he developed a machine that could count these physical, the physical strokes that are entered. He sped things up, but the problem was the US was still growing. So he sped things up so that they could count all of this data in 10 years before the next census, but ultimately data caught up with him. And in 1890, Herman Hollerith, a statistician, developed the electric sorting machine. And he took the time that it took to count from 10 years down to 1 year. And we're going to stay with him for a while, because what happened? IBM came in, the one that you never get fired for hiring, and they took his technology and they improved on it. And Mr. Watson, the eponymous AI chief, he scaled the use of these punch cards using the holorith technology. And what he did is he made competition within IBM. So he, for example, had a group in Rochester and a group in New York competing against each other, a little skunkwork operation. And they competed to develop technologies to optimize the holorith punch cards. And ultimately, by mid-century, they were producing about 5 to 10 million of these cards every day. Mid-century, things changed because of this guy, Claude Shannon, our data hero. And he came in, and obviously for half a century or more, these thin pieces of cardboard with tiny little rectangles had made the world quantifiable. But Claude Shannon changed that. He gave birth to digital data. And Claude Shannon was working at MIT, and he saw the limitations of, analog logic, these clunky bits and bobs machines that were used, they were called differential analyzers, to calculate things. And they broke down all the time, they weren't accurate. And so he wrote a seminal piece that he published in 1948 called The Mathematic Theory of Communications. A revolutionary piece, because basically he said that if you move things as zeros and ones, you're never going to get errors, right? So you have reliable storage, you have reliable transmission, and you have precise mathematical way of moving data from point A to point B, which is, of course, the foundation to everything we're talking about in this room today. The foundation for the internet, the foundation for mobile networks, the foundation for data compression. But it took a while for us to get how valuable what he was proposing was to what we could do with data. Because really all we used it for is to continue to count data more effectively. And so you had the UNIVAC machine that came up with magnetic tape and vacuum tubes, and then IBM said, oh no, we have to get our business back, and they came up with the IBM 701, and the only reason really they dominated was they had a really good sales force. And nothing really changed until the Cold War. And when the Cold War came, basically everybody said, hey, we have a mission now to transmit data, what Claude Shannon was talking about, more effectively. Why? Because if there's a bomb, we need to make sure that data gets from point A to point B. So we all know about ARPANET and how they put together a system with packet data where data was broken down into small packets and ultimately transmitted independently across the network. And we know that that's valuable, not just because it's efficient, but it was designed to be resilient, so if there was a bomb, the data still got from point A to point B. And then in 71, there were 15 nodes on the network. In 73, there were 35 nodes on the network. In 76, there were 63 nodes on the network. And it got bigger, and then you had your TCP/IP that came in, which basically allowed us to have the language and structure of data in our modern economy. And then Leon Bossack and Sandy Lerner came up with a way of using a router to move that data between networks. Actually, my understanding was that, whether it's true or not, is that over breakfast or lunch, there is what we call the 3-napkin protocol, which is written literally on 3 napkins. They came up with a method of routing data packages between different computer networks. But in between that, we had Ray Tomlinson, who put together, obviously, what we know now as email using the @ sign. And over the next few years, we had David Crocker, who put together the protocol that we now know of as email with from, subject, and date. And we came up with something which was about communicating data. And that's the first time we have the human as part of the data journey. Up until that point, it was just an abstract notion. Now the human is getting involved, and it becomes more personal. It starts to accelerate the way we communicate. And, of course, we now have the birth of HTML. You have Tim Berners-Lee, who came up with something that is now seen as the World Wide Web. The big contribution that he made was not just that, but that he made it without a patent, and he made it open source, so there was free access and a global adoption of the solution. And that then was adopted into basements across the world, and you had 2 people and a dog coming up with solutions in garages, including, of course, Jeff Bezos, and building solutions on top of that infrastructure. And Jeff Bezos, being the one that survived the dot-bomb, patented, buy in one click, and took it not only on, the commerce journey that was on the screen, but took it into the IoT, allowed you to click on contraptions that eventually would be similar to Alexa, but you could click on something and immediately order it. So you could click on that, and if you didn't click on it fast enough, you probably have to get this. And then ultimately all this had to be stored somewhere. So 7 years before any other company, Amazon realized that having this all stored in one central place was a smart thing. So they build a modular, interconnected plug-in solution, right? That was like Lego blocks for tech. And with AI solutions, with databases, with API gateways, with global storage in minutes, plug and play. And we all know how profitable that is. We know that delivering goods from the Amazon storefront is not where they make their money. 10x of their profit comes from their back-end AWS solution. And if we want to go a parallel journey, just step back a little bit, there was a journey in parallel on the telecom side. So my friend, Marty Cooper, I had a chat with him when I was writing one of my books, and he's the guy who made the first phone call, right? He, on April 3rd, 73, and he made it off the device that he created at Motorola. And I said to Marty, "What's the future, Marty?" And what Marty said to me is, the future cell phone will be a collection of personal devices and personal applications specifically tailored to its owner. It'll be distributed in optimum locations on the user's body and will automatically and continuously optimize its configuration. That's where we're going. The human is now embedded into the data experience, right? Wearables, the future vision of cybernetic augmentation. And this guy knew that so well. So when Steve Jobs stood on the stage in 2007, he says, "Hey, data is something you can touch." And that was explosive, because now you could pinch and suddenly data opened up. And that profoundly changed our relationship with data. And that is meaningful, and it's explosive. And we continued to embed the human in this process. What's happening now with everything around us is that we are more enabled and embedded into that data experience. And that's what's happening now with ChatGPT and other platforms. It's also starting, like we had with the Cold War, a bit of a journey that we're going to be going through for the next few years. We have, obviously, Stargate, which is Trump's attempt to put together a strategy for the US around AI. You have SoftBank and OpenAI at the table. You have the barons of data, Larry Ellis, Masayoshi Son, Sam Altman, all trying to put together a strategy for next-gen data. And there is a new data arms race. And we're either playing in it or we're not playing in it. So where is data going to be? Is it going to be in Texas, in Stargate, or is it going to be floating up in the sky, in optimal cooling environments with a lot of energy? Is it going to be there? I don't know. But we're heading to a new world, and ultimately that world started with recording data, collecting data, counting data, transmitting data, communicating data, storing data, touching data, and now speaking to data. Continually, the thesis is the same. If you don't act on that data, if you don't take ownership of that data, your backyard is not going to be able to accelerate and dominate. You've got to own data. And if you don't own data, there's a huge risk, right? If you don't own data, we talked about it here, I know, and it'll be a continual leitmotif throughout the day and tomorrow. You have a loss of data sovereignty. You have economic leakage. You have an erosion of talent and innovation, which is probably your biggest liability. Data, it's a pancake, right? It's not an infrastructural discussion because everything in our economy is built on this. And if you don't build that foundation, you can't build regional specific platforms to address the climate risk, to address clean energy, healthcare, data as a service solutions, robotic process automation, optimizing the way that we work as governments and independent organizations. Cybersecurity has come up many times. Ultimately, what is important for us is to understand where we've been, to know where we need to go. Thank you.